Hello and welcome to ThePrint. I am Mohana Basu, Assistant Editor, and today we are at ICAR-IARI, which is at the Pusa Road in New Delhi, and we're standing in the middle of a beautiful field where different new varieties of different kinds of grains is tested out. We are at the wheat field right now, and with me I have the director of the institute, Dr. A.K. Singh. He, of course, he's the face behind many of India's, newer basmati varieties, Pusa basmati varieties, and he is here today to talk about this new variety of heat-resistant wheat, heat-tolerant wheat, which is planted right behind us here right now. And this particular variety has been developed to make India's wheat cultivation resilient to the temperature stress. So he's going to tell us all about this new variety. Thank you so much, sir, for giving us your time. So it's very exciting to be in the middle of this. This is all cutting edge science. It's right out there. As far as I can see, we just have different varieties of wheat. We are here today for this. So tell us a little about this particular variety.
So thank you, Mona, for coming to ICAR-IARI, the seat of Green Revolution. And we are in the mid of a wheat field, and the variety just behind me is HD3385. This is a variety which is a special kind of variety which has been developed for terminal heat tolerance character. We know that when wheat is sown timely, that is from 1st November to 20th of November, or late sown wheat, during the time of grain filling, when grain is at milky stage, sometimes because the temperature going up in the month of say March, towards end of March, it faces high temperature stress, and that milky stage of grain filling, if it is subjected to high temperature stress, the grain filling does not get properly done, and the grains are shriveled, and because of that the productivity is reduced. I remember last year it was sometime around 27, 28, 29th March that there was a wave of heat, and that had effect on wheat production to a certain extent.
And that is kind of why the government is very proactive this year to make sure that the crop does not, it is monitored, because we also saw very high temperatures.
Right. So Honorable Minister of Agriculture has constituted a committee which is looking on daily progression, how the temperature is moving and how it is going to affect the crop, if at all, and what are the mid-course correction that needs to be taken in order to prevent the crop from temperature stress if it happens. So far situation has been fantastic. Temperature has been, the maximum temperature has been below 35 degree, and it is predicted till 16th of March, the data is available, that both minimum and maximum temperature are going to be 2 degree below the normal temperature, so there is no question of worry as of now. But coming back to this variety HD3385, which has been developed for terminal heat tolerance, and as I was saying that when wheat is timely sown from 1st November to 20th November or late sown, it faces the terminal heat, and because of that stress productivity goes down. So one way is that if we can prepone the wheat sowing towards say October, middle of October, 25th of October, about 15 days early, then we get 15 days additional time. Now these varieties which have to be sown early, they require special characters. In the month of October, the soil temperatures are a little high, so we need to have a little temperature tolerance for germination. And then also if the normal wheat varieties which are recommended for timely sown condition, if they are sown early, then they have a tendency to come to flowering early, and because of that early heading results into poor yield. So in these varieties we have incorporated a gene called weak vernalization gene, and therefore because of this gene, even if the varieties are seeded early, they will not come to flowering unless a minimum threshold of temperature is reached, and therefore they get enough time for vegetative growth and to accumulate more of biomass. And higher the biomass, it is the biomass that is converted into grain. Almost, most of the modern day varieties, they have got a harvest index of 45 to 50%. So higher the biomass, even if harvest index is constant, we can have higher productivity. So that's our goal, is that prepone seeding by 15 days, allow varieties to accumulate more biomass, allow them to fill the grain early so that they escape the temperature stress towards the terminal phase.
Right. So, but if we do so early, we have another major problem that is, the paddy crop being there's not enough time between the two crops, and that is why we have the problem of stubble burning. So, how can we tackle that in that case?
So that's a very important question you have asked, and in fact our institute developed a paddy variety called Pusa 44, which is the longest duration variety. It takes about 150 days duration. But for last 3 years, it's the government decision, collective decision, that we have stopped producing breeder seed of Pusa 44. And our focus in rice breeding program for whole of Punjab, Haryana, Western UP is to really develop varieties which are in a duration range of 125 to 130 days seed to seed. So that from 1st June, if we start 10th June, the planting time starts, it should complete its life cycle by, say, end of September or middle of October. Our focus there is to develop short duration rice varieties which are equally high yielding as the long duration paddy varieties. And if we are able to do that, the farmers will definitely not like to go for long duration varieties, because 155 days duration varieties will take at least 5 to 6 more irrigation, and the same yield can be obtained with 135 days varieties. Farmers will definitely like to do that, and that's what our attempt is. And there and we have number of early varieties of paddy as well as, for example, Pusa Basmati 1509, Pusa Basmati 1692, Pusa Basmati 1847. These are the 3 varieties of basmati rice which take about 125 days seed to seed maturity.
And these are very popular among farmers.
Yes.
I should tell my viewers that just a few days back there was a Kisan Vigyan Mela right here in this campus, and there were farmers, hundreds of farmers here, just sitting from like 5 a.m. in the morning waiting for bags of this seed which was being distributed by the institute. In fact, we have some visuals which we will show here from the whole fanfare, I would say, gathered around you. So coming to the science of it, like, I think I would like to know, I'm very interested to know how exactly this works. How the basics of how we come to how you produce these new varieties.
Right. So, there are conventional ways of doing things, and one of the greatest science of plant breeding, which has used a number of approaches, like, selection from the existing variation, then introduction. If there is a crop which doesn't exist in your country, it is elsewhere, you introduce it. Crop like soybean, they were never native to India, they were brought from outside. Then there is a method of breeding called mutation, where you can use certain mutagenic agent like X-ray, gamma ray, or chemical mutagens to create changes in the DNA and thus changes in the phenotype of plants. So mutation breeding is another approach. Yet another approach is polyploidy breeding, where you manipulate the number of chromosomes. By increasing, decreasing number of chromosomes, you can create variation in the crops. But the most commonly used method by the breeder is hybridization, where you take 2 parents which complement each other. For example, a variety has got higher yield, but it has got susceptibility to a particular disease. On the other hand, you have another variety, it's a land race or farmer's variety, which is low yielding, but it has got high level of disease resistance or temperature tolerance. So you make a cross between 2. With each flower of wheat spike, it has got male flower and female flower. We open the flower, remove the male flower from there, that is called anthers, and then we take the pollen from the other complementary parents and pollinate this emasculated flower of the female parent, and the seed thus obtained is a hybrid seed. And in hybrid, the genes coming from two opposite parents, they go under multiple recombination. And as a result, the progeny that is produced has got a combination of good and good, good and bad, bad and good, bad and bad. But a plant breeder's job is to identify those progenies from the segregating generation which have got the useful combination of characters from both parents. And this whole process takes almost 10 to 12 seasons. Like if we are taking 2 crops in a year, then it takes 6 years time minimum to develop a new variety. If we are taking only 1 crop a season, then it will take 10 years to come out with a new variety. So that's the kind of intensive research work that goes through hybridization. We develop varieties that are called pure line varieties. And pure line varieties are the varieties where seed can be saved by farmers, used for planting next crop. There are another set of varieties which are called hybrid varieties, where 2 parents are crossed and the seed thus produced is given to farmers as a commercial seed. But in this case, farmers have to purchase fresh seed every year. So these 2 are the major kinds of varieties which are developed through hybridization. Now, of course, number of new methods of breeding, hybridization, which is supported by molecular marker assisted breeding, where we identify DNA markers which tag each and every important genes. So in segregating generations, using those DNA markers, we can identify plants which are resistant, which are high yielding, and so on at a very early stage. Otherwise, for example, if you have to identify a plant whether it is disease resistant or not, then you have to take pathogen, inoculate on the plant, look at the plant phenotype whether it is getting disease or not. But if we have a marker linked to disease resistant genes, we just need to take a small segment of leaf like this, isolate DNA from this, use the DNA marker through PCR technique, and we will note that yes, this plant has got disease resistant gene at a very early stage. So molecular marker assisted breeding has helped in expediting and fastening the breeding process, and large number of varieties now we are developing through molecular marker assisted breeding.
So how long did it take for this variety to be developed, from lab to the field now?
So this variety is developed through conventional breeding, and this has taken almost 6 years to come to this stage. Now we have protected this variety with the Protection of Plant Varieties and Farmers' Rights Authority, and we are partnering with the industry to produce the seed in large quantity, and then go to the farmers with this new variety which has got terminal heat stress tolerance.
So that means 6 years back, or probably before that, your team already had the foresight to look at developing varieties that would be climate resistant. So since when have you been working on that down that path? Because now is the time that everyone needs these crops, whether it be it's not just heat, right? It's also like extreme cold, drought. There are different kinds of needs that different crops will have. So how long has this
See, at this institute we initiated the research work on global climate change impact and its mitigation strategies as early as 90s, and a center for climate resilient agriculture called CESCRA was established. And I tell you a very interesting story. Earlier the global estimations had said that the Indian rice will emit methane gas to the extent of 37.4 million tons. And Indian rice was declared as sort of culprit. But when our detailed investigation was done at this institute, with fine experimentation, capturing the methane from paddy field throughout the country, quantifying its effect, finally we came out with a publication which said that it's only 3.7 million tons, not 37.4 million tons. So we have been aware of the climate related aspects, and we have got a facility of FACE and FATE, where we have control conditions for elevating the carbon dioxide, for elevating ozone level, for elevating temperature level, and a combination of all these three, and then grow the different varieties of crops which are conjured in, for example, in our national gene bank, take them out and see that some of the varieties which were selected by our predecessors, our ancestors, what specific good traits that they have. And once we identify them, also we have got a Nanaji Plant Phenomics Center, Nanaji Deshmukh Plant Phenomics Center, and this center has got the facility to identify potential germplasm which would be having high value under the conditions of climate change.
Right.
So once we identify those germplasm lines, we use them in the breeding program to develop future varieties to address the issues related to climate change, whether it is carbon dioxide or temperature or ozone related issues. And that's where our institute is working very intensively in this particular area.
Right. So, coming to right now, we've seen that over the last couple of months, we have had several approvals for GM crops, and in such a scenario where finally the perception for GM is it seems to be changing in the government. How do you see the signs of crossbreeding, hybridization? What is the future for that? Are there advantages of this particular method over GM?
Well, I see it in a different perspective. A mechanic has got a toolbox, and in toolbox he has got number of tools for different problems. For a plant breeder also, these different technologies, whether it is mutation breeding, polyploidy breeding, selection, hybridization, or transgenic development, or genome editing, these are different kinds of tools. The ultimate goal is to develop a variety which will have resilience to climate, resistance to biotic stresses, higher productivity, better grain and nutritional quality. So that's the ultimate goal. Now, these new tools are very much precise. For example, when I talk of mutation, which is a sudden, discrete and discontinuous change in genetic material, and if we do it by artificial mutagenesis or by spontaneous mutation, we do not know where mutation is going to take place in the genome.
Right.
A gene in which you are not interested to change will change, and the gene that you are interested in change will not change. But the science like genome editing is so precise that it will make change in the gene that you really want to change. It becomes highly targeted to create a desirable phenotype. Likewise, in transgenics, there are certain genetic variability which are not available across the species which are sexually compatible. As I said, in hybridization, we need to cross two plants which are genetically diverse, which complement each other, but they must be sexually compatible.
Right.
There are species, for example, if you want to transfer a gene from a bacteria to plant, you cannot do it because bacteria cannot hybridize with plant.
Right.
So under those situations, we have to use the technologies that can help us transferring the gene across the sexual barrier, and that's what is done in case of transgenics.
Right. In fact, the GM potato variety, that is actually a hybrid of a GM crop that was already developed in the US with the popular Indian variety. So it's not like the two are too far away. They will go hand in hand in the future.
So that is when, for example, once we have transferred a gene from a bacteria, for example, if we take up BT cotton. So BT gene was transferred from bacteria Bacillus thuringiensis to certain cotton variety, and that cotton variety has been used as a donor for transferring that gene then to a large number of other hybrids.
Right.
So now we have almost 12 million hectare area under cotton is planted to BT cotton, and that protects the crop against the Helicobacter or Mijera insect that bores into the ball and results into poor production.
Right. So what is now the plan for your heat-resistant wheat? Is there a commercial? I know that there has been a commercial, but I'll let you address that.
So as I said, that we have protected this variety with the Protection of Plant Varieties and Farmers' Rights Authority. And with that we get a breeder's right. And exercising the power conferred upon breeder under breeder's right, now we can go for commercialization of this variety with the industry partner, and that's what we are doing. We have signed MOU with some companies, and this year they have taken large scale multiplication cum seed production exercise, and next year I hope that this variety will see the light of the day.
Right. We hope so too, sir, because climate resistant crops are the need of the hour, because we are seeing extreme temperatures across different parts of the country, and the most important thing, one of the major problems or the issues that everyone raises is food security.
Sure.
And that's what this institute is working towards. Thank you so much, sir, for all your time and explaining everything to us so patiently. Once again, this is Mohana Basu, Assistant Editor at ThePrint. We are bringing this story to you from the ground. Behind the camera with me is Pooja Kher. If you do like what you see, if you are a fan of our coverage, if you like our coverage and want us to do more of this kind of work, do consider paying for a subscription to ThePrint. You can do so through the link in the description box below.
Thank you so much, Mohana. Thank you.
Thank you.